Here, we want to talk about the conveyors. So conveyors basically are similar to the queues. However, the movement of the parts or entities in the queue are done based on the speed of the conveyor and based on the length of the conveyor. So we can specify a specific length and a specific speed to the conveyor, and that specifies the speed by which the entities are moved from one location to another, or the entities are moved across the whole simulation. And this is as opposed to what we had learned about the queues, because for the queues that was not the case. For the queues, the speed does not matter, or the length, unless it's significantly different between different models. So the length is not going to matter as much as well. So the queue is more like a placeholder. But for the conveyors, as I said, the length and the speed of the conveyor matters in terms of how long these entities will stay in the system and how long will it take for them to go from one location to another. So the first example that we are going to learn related to the conveyors is a car wash example. So please create a new model in the folder for week 9. The name of the model is Sandymoss Car Wash Single Conveyor. So in this model, in this car wash that we're going to model, the cars come to the entry point, and from there they are put on a conveyor, where on the conveyor they go through the process, the water, the cleaning, the drying, everything happens on that conveyor. And when they are done, then they go to the exit and leave. This conveyor can hold only 3 cars. One car has to leave before we can put another car on the conveyor. The car entry or the car exit have capacity of infinity. So for this conveyor, which has the first in, first out rule, is a conveyor. The cars are on this conveyor, they cannot pass each other. There is the first in, first out rule, and it's a conveyor, and it can hold only 3 cars, wash 3 cars at a time. One other piece of information here is that this conveyor has the length of 400 feet and the speed of 20 feet per minute. We also know that the cars come to this system one at a time within the arrival time of 15 minutes, exponentially distributed. So please create a model in folder for week 9. Name your model as Sandymoss Car Wash / single conveyor. Put your locations, create your entities, create your arrivals, and we do the processes together. Guys, let me also mention that at car wash entry and car wash exit, there is a processing time. So at the entry to pick the type of car wash that they want and so forth, and at the exit to maybe pay some tip and things like that. So the processing time at the entry point and the exit point has normal distribution with average 8 minutes and a standard deviation of 2. So this is the processing time at the entry point and at the exit point. Okay, so these are my locations: entry, car wash, and exit. I'm sorry if I said, I think I wrongly said car exit has capacity of infinity. It has capacity of 1. Not a big deal. These are just, again, the setups of the model as it is in the book, and I just want to make sure we get similar numbers. So let's keep it as 1. And for the car wash, make sure it has capacity of 3 because it can only hold 3 cars, and it has the first in, first out rule. Some piece of information I gave to you guys today regarding this model was that the car wash, the conveyor that takes care of the car wash, has the length of 400 and the speed of 20 feet per minute. So we have to see where to put these specification. Okay, so these are the specification of the conveyor. So if we go in the location, when we click on the conveyor, this window opens, and we always remember, I always said, okay, make sure it's a queue, not a conveyor. But here, no, keep it as conveyor. We want it to be conveyor. And the length is 400. And in the conveyor options, here we can specify the speed as well. So the length is 400 and the speed was 20 feet per minute, right? That was the number. Yeah, the length is 400 feet, and the speed is 20 feet per minute. So we can specify those here, and that's it. Press OK. So our entity is cars, and our arrival is that the car go to the car wash entry one at a time from the start of the simulation, never leaves this empty, always put 0. For as long as we run the simulation, occurrence is infinity, inter-arrival time is 15 minutes, exponentially distributed. And then for the processing is simple. I'm just going to pick the entity car, goes from entry to car wash, and from car wash to exit, and from exit to, we'll exit from the system. Okay. The processing time at the entry is normal, 8-2, and the same for exit. How about the car wash conveyor? How come I don't have any wait time here?
The wait time is a function of the length and the speed.
Exactly.
Of the conveyor.
Exactly. The wait time at the car wash is captured in the simulation model automatically, because when I put an entity or a car on this conveyor, depending on the length of the conveyor and the speed of the conveyor, it will take some time for this entity to go to the other side and then to the exit point, and that will take care of the car wash time. So the speed and the length of the conveyor will take care of the car wash time, or the time it takes for this entity to go from this point to this point at the end, which is the car wash time here. So I don't need to worry about that. And here, let's run this 400 hours. 100 hours. Like we had this. Let's run the simulation 100 hours. Okay, so this is the number of exits I got, about 400 cars. Save this model. And I want you guys to create another model. So in this model, we are going to learn to work with multiple conveyors. So I want you guys to please create another model in the same folder for week 9. Name your model as shipping boxes - multiple conveyors. Okay, you see the name of the file on the top. Name your file as shipping boxes - multiple conveyors. And then here, I have 3 conveyors, conveyor A, conveyor B. So I put boxes type A on conveyor A, and I put boxes type B on conveyor B. And then these boxes go to the shipping conveyor, both of them, no matter if they're box A or box B. Then they go to the shipping conveyor, and from there to the shipping dock, and then exit the system. Box A arrives to conveyor A with an arrival time of 5 minutes, exponentially distributed. Box B goes to conveyor B with an arrival time of 2 minutes, exponentially distributed. And as I said, then both box A and both box B go to the shipping conveyor and then to the shipping dock and then leave the system. Conveyor A has a length of 100 feet, a speed of 50 feet per minute. Conveyor B has a length of 100 feet, a speed of 30 feet per minute. And the shipping conveyor has a length of 200 feet, the last line, speed of 20 feet per minute. So I want you guys to please create a model, as I said, call it shipping boxes, multiple conveyors, - multiple conveyors. Create these 4 locations. For all of the locations, keep capacity of infinity. For the conveyors, keep the queuing rule as first in, first out. I want that to be the queuing rule for the conveyors, but for the shipping dock, no queuing rule. We have 2 entities, box A and box B, and you have the inter-arrival information here. And you also have the information related to the length and the speed of the conveyors.
For the conveyor information, they're both labeled as conveyor A.
Thank you. And yeah, so the information of the conveyors are here. And So please create the entities, create the locations, entities, arrivals. You can do the processes as well, and then I'll check yours and then do my process. Okay, so these are my locations: conveyor A, conveyor B, shipping conveyor, and shipping dock. These are my entities: box A, box B. These are my arrivals. Box A goes to conveyor A. Box B goes to conveyor B. One at a time, for as long as we run the simulation interval time of 2 minutes exponentially distributed. Box A goes to conveyor A one at a time from the start of the simulation for as long as we run the simulation interval time of 5 minutes exponentially distributed. And now let's go to processing. So here I'm going to pick box A, which is already at conveyor A, and from there it goes to the shipping conveyor, and from the shipping conveyor to the shipping dock, and then from shipping dock to exit. Then box B goes from conveyor B to shipping conveyor, goes from shipping conveyor to shipping dock, and from shipping dock to exit. Okay. When we were on the locations, we had to make sure that our conveyors also have the right length. So conveyor A has 100 feet length and speed of 50. Conveyor B has 100 feet length and speed of 30. Conveyor A speed of length of 100, speed of 50. Conveyor B speed 30. Conveyor B length 100, speed of 30. And for the shipping conveyor, length of 200, speed of 20. Length of 200, speed of 20. I'm not changing anything else. Okay, so we do that, and then we take care of the processing. And again, I don't need to put any wait time here in operations because the length and the speed of the conveyors take care of how long it takes for this entity to go from one side of the conveyor to the other side and finally to the shipping dock and leave the system. I also asked you guys to calculate how many box A and how many box B left the system, and this is something that system automatically calculates for you. That's total exit related to each entity, but I wanted you guys to calculate that using variables as well. So I go to variables. I have two variables to count how many box A and how many box B leave the system, and both these variables are integer. Then in the processing, if I want to count number of box A that have left the system, where is the right place to do that? At shipping dock, when box A leaves the system. Here I'm going to say increase. The name of the variable was count A. So I'm going to increase it here. And the same for box B. And when they are at shipping dock and when they are leaving the system, I'm going to say increase count B. And I'm going to run this simulation for 10 hours. And these are the number of exits I got for box A and box B. And obviously you see my single capacity stats, location stats is empty because I don't have any location with single capacity. So that's why this window is empty. And here I see my variables, count A, count B, number of entities, number of box A and box B that have left the system, which is equal to the ones that the system has calculated for us automatically, total exits.